Welcome to this Capstone Explainer. I am absolutely thrilled to have you here today. We are going to uncover the ultimate structural secret to executing massive, complex offshore EPCI projects. You've learned the technical and commercial mechanics already, but now it's time to reveal the organizational glue that holds every single piece of this giant puzzle together. Picture this, because we've all been there. 3 departments, 3 different buildings. Heck, sometimes 3 entirely different countries. What happens? Every simple question between the project management team, engineering, and procurement turns into an email. And then that email bounces around, gets delayed by time zones, sits in an inbox over the weekend, and bam, it's a 2-day round trip. And every single one of those round trips lands squarely on the exact critical path we spend all our time trying to protect. So why does that actually matter? Well, let's look at this number, $1 million. Every single day, a fabrication yard is frozen, or a construction vessel is just sitting idle out on the water. It burns roughly $1 million a day. And honestly, it's almost never because of a catastrophic technical failure or, bad weather. Most of the time, it is simply because somebody, 18 months earlier, issued a drawing 3 weeks too late because they were waiting for those siloed emails to clear.
Section 1, the task force solution. Okay, let's dive right into this.
We need a structural solution that physically stops this $1 million bleed, right? Enter the integrated project team, better known as the task force model. So what exactly is it? It's co-locating the project management team, engineering, and procurement into a single functional unit. We're talking about one floor, one set of priorities, reporting into one single project structure. And notice what this is not. It's not a matrix organization where people have divided loyalties. Actually, scratch that, it's not even a weekly coordination meeting where issues just get logged on a spreadsheet. It is a total geographic collapse of departments. By mashing PMT, engineering, and procurement into one continuous unit, you completely change the dynamic of the project. The question and answer icons that used to travel continents over an email server, now they literally travel meters across an open plan desk. You don't draft a formal query anymore, you just lean over the desk and ask the procurement manager directly. Section 2, collapsing decision latency. So what does this actually do to our complex network of interfaces? Well, in any project, you have external interfaces and internal interfaces. You absolutely cannot eliminate external interfaces, where your scope physically or digitally meets a third-party scope. Those just have to be mapped out and actively managed. But internal interfaces, the ones between your own engineering and procurement teams, those can be eliminated almost instantly by co-location. Internal interfaces between your own isolated teams actually cause way more delay than external ones ever do. The task force kills those internal battery limits because, frankly, you stop treating your own colleagues like third-party vendors. Here is the absolute golden rule to take away. Co-location collapses decision latency. It doesn't magically make your engineers work harder or type faster. What it does is ensure that critical decisions happen in hours rather than weeks. Every technique in EPCI execution, from that 3-week workfront buffer for the yard to the monthly risk report, completely depends on decisions being made fast. The task force is the structure that makes that speed physically possible. Section 3, same talent, different geometry. To really grasp this, think about a Formula One pit wall. You've got the strategist, the race engineer, and the head mechanic sitting shoulder to shoulder, staring at the exact same data. When a tire strategy needs to change, bam, the call gets made in seconds. Now take those same 3 excellent, highly trained people and stick them in 3 different cities with an email chain between them. That car sits in the pit lane, losing the race while the decision routes itself. As the saying goes, the talent didn't change, the geometry did. Section 4, the economics of co-location. Now, I know what you're thinking. In the real world, executives are going to push back hard on the upfront costs of this geometry shift. So, I'll ask you directly. Setting up a co-located task force costs roughly $2 million in relocation, office space, and IT setup. When you're sitting across from a skeptical finance director, how do you mathematically justify spending $2 million just to move people's desks? The answer lies in stark, undeniable math. 2. Let that sink in for a second. It only takes exactly 2 avoided idle days to pay for the entire task force setup at $1 million a day. Just 2. Everything after those 2 days is pure margin. On a project where a single frozen interface can cost you $12 million in commissioning delays, co-location isn't some luxury overhead. It is, without a doubt, the absolute cheapest schedule insurance money can buy. Section 5, 4 stages complete. Let's move on and see how this all builds together. Look at how far we've come. We started by learning how to sequence engineering to feed a yard and how to rigorously manage external interfaces. We moved into the yard, handling the logistics of heavy lifts and driving the asset from static mechanical completion to live commissioning. Then we tackled commercial realities, defending the contract scope and employing the roadmap to recover a stalled project. Finally, we looked at strategy and selecting concepts that survive the price curve. The co-located war room is the absolute core engine that makes the incredible speed and alignment required for all these disciplines physically possible. Which brings us to our definitive takeaway. You now know the exact structure that ties a multi-billion-dollar EPCI project together. One team, co-located, with absolutely no internal battery limits to hide in. You've got the tools, you have the strategy, and now you know the geometry required to win. So as you look at your own projects, I leave you with this one question. Are you ready to finally tear down those silos, or are you going to keep paying $1 million a day for your own internal battery limits?